Thank you. Thank you for having me here. It's a great opportunity. I work with bee diseases. I run an inspection program in Pennsylvania. I do a lot of research on bee disease. And so when you're asked to give a talk like this, it's nice to remind yourself first about why I got into bees and what a great creature they are. And so I want to spend a little bit of time talking about that before I talk a little bit more about the colony collapse disorder. Honeybees are a passion of mine, and as my patient and loving and kind suffering wife can attest, I can talk for hours about bees. And of course, I don't have hours, and so I do, however, want to talk a little bit about what a marvel they are as organisms. And so when you look at this, there's a couple of things I'd like to point out. First of all, of course, you're seeing these eyes, and in fact, there are 5 eyes on a bee. There are these 2 large compound eyes on the side, and each of those eyes has 1,900 lenses, and so each one sees the world at a slightly different angle. And so this gives them a very different perspective of the world than we have. They also have these little bristles or hairs coming out of those lenses, and that measures the speed of wind. And you can imagine that's pretty important, because if you're flying upwind, you want to be able to adjust for that when you're flying downwind back home. Also, there are a couple of these. You can see one of those eyes in the top there, the ocelli. These are very simple eyes. They see light, and they sort of act like a bladder in a fish. So that way the bees know if the sun's up, I have to fly straight. This is very handy, except if there's snow on the ground and you go flying, because the light reflects and they all dive into the snow, which is always an unfortunate thing when you see that in the winter. Another thing you can see is the antenna. And these antennae are sort of the microchip kitchen marvels of the universe, because they have everything in them. They actually have 2 joints, and those joints are what bees use to listen. But you can imagine if you're a bee, you'd get a headache if you heard buzzing all the time. So they're very attuned to very, very specific sounds. And those sounds are, in fact, the sounds or the vibrations bees make when they dance. So when bees are out in the field and they find a really good nectar or pollen source, they come back and they dance and they wobble their abdomen, and if they really like it, they wobble really hard. If they sort of like it, they wobble sort of. And the other bees can hear that and then know within a meter of where that flower source was, so that they can go back there and check that out. Also, the antenna is used for smell, so they smell with the antenna, they taste with their antenna, they can measure carbon dioxide levels with their antenna, and they can take the temperature with their antenna. So this is, in fact, what we should be designing our new ovens with, these antennae of bees. Of course, no story about beekeeping is complete without a little bit of talk about the sting, or the stinger. And I do want you all to ooh and ah at this one big picture here, because I had this posed. I went to the photographer and had all these great pictures taken, and then he realized the next day that he had put the wrong lens on his camera. And so you can see I ran out of flesh without stings, so there's another sting mark just in front of that bee. But the point of a bee sting is, of course, it's colony defense, and bees are very reluctant to sting. They don't want to sting, because when they sting, they die. And the reason for that is that, you can see in the upper picture there are these barbs, and those barbs act like a saw, and there's some muscle tissue there which saws back and forth, digging the stinger deeper and deeper, and then that sting gland, which is on top of that, keeps pumping venom in. So the key, if you ever get stung by a bee, is to get that stinger out very quickly. So you want to scratch that stinger off very quickly. You know, a lot of people take credit cards out and take their time. That's a great way of making sure you get more venom in you. So you want to get that out very quickly. And as a beekeeper, if you become an experienced beekeeper, you get very good at the butt removal method of stingers. There's a very big difference between bees and wasps. And wasps give bees a bad name because everyone thinks they got stung by a bee, and most of the time it's a wasp. And the biggest defining trait that makes it a bee versus a wasp is the hair. And so bees are covered in hair. Bees are fuzzy. Bees are very fuzzy. And that hair, in fact, when the bees fly, builds up an electric charge. And that electric charge means that when they land on a flower, the pollen actually jumps onto the bee. And then the bee is able to rake that pollen off with her legs, put it back on this pollen basket, the yellow ball in the back there, and bring that back to the home. And that whole story about bees and flowers is a very important one, because in fact, bees and flowering plants evolved together. And without bees, we wouldn't have flowers. In fact, flowers in many ways are the first form of advertisement. This, in fact, is a tulip flower and is really just a big, gaudy billboard on the side, and, on the top of tree canopies. It's loud, it's bright, it says, "Come visit me." In fact, it has some creative advertisement features. It smells, so it's attracting bees in. And if you look at this rather plain white flower on the side, bees see an ultraviolet. And so several flowers that look maybe normal to us or plain to us have those orange or those darker marks there are what we call honey guides. And they're sort of like the big H on a hospital that say the helicopter should land here. It's telling the bees, land here, and this is where the nectar reward is. Having said that, honeybees are imported. They're not native to America. And there are a lot of other flowers out there that are pollinated by our native bees. And there's a big movement to try to encourage people, backyards, and farmers to encourage habitat for these native bees. There's a great website, pollinators.org, dedicated to sort of that preservation. Here we see a bumblebee, and there are actually many species of bumblebees that are going extinct right now for unknown reasons. And they pollinate a lot of the solanaceae, so the tomatoes and the potatoes, and when they buzz pollinate. So when they land on that flower, they buzz and the pollen falls out. And so that makes honeybees not as efficient for certain plant types. Also in the top corner, we have the alfalfa, and alfalfa is very important. Honeybees are used to pollinate alfalfa. However, they're not as efficient as leafcutter bees, and that's because alfalfa has this trip mechanism. So when a bee lands, it trips and it hits it on the head, and honeybees get smart to this and avoid the trip mechanism. The alfalfa leafcutter bees are a little stupid, and they just keep coming back for more. Honeybees are vital to the American agricultural system. We've developed an agricultural system which is monoculture, which means we have acres and acres of plants that come to bloom in one period of time, and we need to bring a lot of bees or pollinators into that area for a very short period of time. We have to get them out before we start spraying our insecticides, and we need them right there for the bloom. And in fact, half the colonies in the country are moved on trucks, either up and down the coast and increasingly across the country. So for instance, a Pennsylvania beekeeper will find his hives in January in Florida doing citrus, move up to Pennsylvania. Right now, they're in apple orchards. They'll go to New York in apple orchards at the end of the week. Then they'll go to Maine for blueberries, come down to Massachusetts or New Jersey for cranberries, come back to Pennsylvania for pumpkins before going back down to Florida. And so that's a very typical setup. Increasingly, however, bees are now, 2 years ago was the first time we issued export permits from Pennsylvania to California in February. And that's because of the almond bloom. In 4 years from now, there will be more almond trees in blossom in California than there are bees in the country to pollinate. And so this creates an incredible demand. I was in California in February, and there's a valley. And I looked in that valley, and it looked like there was snow on the ground. And in fact, it wasn't snow, it was beehives. And there were more beehives in that valley than there are in the state of Pennsylvania for those 2 weeks before they go to the almonds. So there's an incredible movement of bees. And it's essential for our food supply that we have this movable force of pollinators. Now, of course, no talk about bees is complete without a little bit of discussion about honey. Honey, of course, is a very rich and diverse source of sweetener. It has a lot of flavors and textures. Just like wine, you can smell it, you can taste the subtle differences. One very famous honey is being produced, or just finished being produced in Georgia, the Tupelo honey some of you have heard of. We heard about leatherwood honey yesterday. There's acacia honey from Arizona. There's apple honey. Buckwheat, if you ever want to grow some hair on your chest, take some buckwheat honey, a very powerful honey. And so there's a lot there, but honey is not only just interesting sweetener, it's also the ethical sweetener. And as we heard here about the importance of economy, if you look at the energy consumption to bring sugar to your table, honey, locally produced honey, is the most carbon-efficient way of sweetening your food. So if we look at this idea or believe in this idea that small things can make big changes, perhaps one of those changes is our choice about what we put in our coffee and what we put in our tea. Those little steps maybe can make a big difference. One thing that we in the scientific community think about is not bees as an individual organisms, but as a superorganism. Because an individual bee cannot survive on its own. It requires the collective. And as a collective, it does a lot of things. Of course, it has different components. For instance, the queen in the top here is really this chemical factory. And she produces a pheromone which puts all the other bees at ease. A bee colony, when you remove that queen, the bee colony will be aware of the queen's removal within 20 minutes, every single bee, and start behaving differently. So there's a lot of this chemical communication that goes on. She, of course, produces as many as 1,500 eggs a day, and so all those bees are her daughters, essentially, except for a couple of drones, which are the ones in the bottom there. And drones basically do nothing. They sit around 20 days, and then on their 20th day birthday, they start flying out of the colony at 1 o'clock every day, and they go in these drone congregation areas, and they fly around in this big mass of bees waiting for a queen to fly through. And actually, when a queen does fly through, they compete for her and they mount her, and it's an audible popping sound when they're successful. And so when they get very excited and penetrate her, they fall over back deadwards in the excitement. And so it's a very interesting life, the life of a drone. And then also when things get tough in the fall, they get kicked out because there's no more, they know it's fall, there's no more chance for mating, and they all get kicked out. So that's the life of a drone. Now also, yesterday's talk, we heard a little bit about how mycelium, the world revolves around mycelium, and we're connected. And that was an interesting idea. I think it may have been a little bit misinformed because I think it revolves around bees. And I'll prove that here today because as an expert, I can look at this frame and I see a couple things. One is in the far corner there's a bee and it's devaving. And what it does is it gets on another bee and it jumps up and down real hard. And it's telling that bee, come on, get going, go move and do stuff. And we call that, of course, the Chef Jeff bee. In the other corner there, we have the hidden kitchen. And the hidden kitchen is where the food supply comes into the colony, the nectar comes in, it has 80% water. But to make that honey, they have to reduce that water down. So they boil off that water by producing heat with their muscles, and they boil it down, and in that hidden kitchen. So you can see in the summertime, as much as 15, 20 pounds of nectar come in, and they'll lose as many as 12 pounds of that overnight in water. Most of that, of course, occurs at 4 a.m. We like to say in the beekeeping profession that it's the second oldest profession of mankind, and that's because we've had a long association. 1,200 years ago, 2,000 years before Christ, there was this cave painting in Spain, and it's a woman climbing a hemp rope collecting honey. Also, if you ever find yourself in Africa walking through the savannas, this indicator bird might land in front of you and do a dance, and you follow it, and will bring you to a honeybee colony, which you then can cut out the comb, and you have to leave a little bit for the bird and take the rest for yourself. So we've had this long association. And in fact, this honey hunting occurs in many places. As we heard earlier, in Indonesia, they have different species of bees, the Apis dorsata or the Apis florea. And these are used in a lot of sustainable work in trying to preserve the forest, don't cut down the forest, but harvest from the forest. The first real beekeepers were the Egyptians. And there's actually, this is still done today, where you can see this cave one. The Greeks were the ones who really specified it, and one of the lessons from the Greeks is you don't usually beekeep naked. But it was the Romans that actually really started managing bees in skeps, and those were how the bees were imported into America. And interestingly enough, they really prized honey because they made very bad wine, and they needed the honey to make the wine taste better, lacking the laser beam, I suppose, that we heard about yesterday. That whole idea of keeping bees and different things is a very interesting story in itself, and that could take 20 minutes in itself. In Yemen, for instance, they have these contraptions in the bottom where they can carry this on camels. Log hives, the one in the top there, is the hive that was used about 100 years ago in the country. But then disease started spreading, and there was a Pennsylvanian, Philadelphia resident, Langstroth, who invented the movable frame hive. And now it is, in fact, illegal to keep bees in anything but these movable frame hives to allow for the inspection of disease. And so this was a very big transition. And of course, that whole idea of disease is one that comes today, and honeybees have been in trouble for a long time. If we look at the varroa mite, which is the top mite here, that's about the size of a dinner plate. If we were a bee, it's like a dinner plate sitting on us, sucking our blood. And those were imported into the country in the 80s. And since then, there were about 4.5 million colonies in the country. Now there are about 2.4 million. So these mites have done a lot of damage to the bees, and they continue to do a lot of damage to honeybees. So in this new case of colony collapse disorder, it's frightening in the aspect that we can't maintain these heavy losses. A very prominent Pennsylvania beekeeper called us in November, and he had moved 3,000 colonies from Pennsylvania to Florida in October, and then after Thanksgiving he went back to Florida, and he found 2,000 completely dead. And we kept hearing other reports of this across the country. A guy, 13,000 colonies, has 3,000 left. And so this level of loss is extraordinary because of the speed at which it happens and the fact that we don't find any bees in these dead colonies. So we got some emergency money, and what we did was we visited California and Florida, and we found apiaries where there were colonies actively collapsing, so strong colonies in decline and dead colonies, and sampled those. And so right now what we've done is we've separated those samples out, and they're going to Penn State is doing a lot of pathology work with Columbia. We've some in North Carolina State for protein and nutrition analysis. We have the USDA, ARS. We're doing some experiments, radiating comb to see how we can reuse that comb and look at that. Some of the preliminary findings, however, you can see in this graphic here. This is the venom sac. My lab is doing the bee autopsies. And so this is the venom sac. And you can see that fuzzy stuff in the top there. And that, in fact, is what we think is mycelium. So it's a fungus. And so we're seeing fungus in there. We're also seeing evidence in the bottom here. You can see the little loops of the kidneys or the malpighial tubules, and we see this scarring, which is an indication of some fighting of infection. And in the top picture there, muscle tissue of the bee's thorax is usually white, which you can see at section B. We're finding black there, and it doesn't take anybody to be a pathologist to realize that black is probably not very good. And so, in fact, what we're seeing is evidence of immune deficiency. So there's obviously immune deficiency, and there are a lot of theories about what that is. One theory we don't believe is true is cell phones. However, saying that, we don't recommend beekeepers give cell phones to their bees because they're social insects, and they'll bankrupt even the most efficient. They also only pollinate blackberries. But we are looking at a new pathogen, perhaps, a new virus or something, and that analysis is coming in. We're looking at environmental contaminants. Is this a new insecticide that's a sublethal effect? Or is this a little bit like a heart attack, where what you're having is that, if you don't eat well and you smoke and you don't drink enough red wine, you get a heart attack? Is there some immune compromise going on here? And so that work is ongoing. I was talking to someone about that even this morning. So there's a lot there. Another aspect of this whole thing is the press. We figured in the last 6 weeks, more press than we have in the last 40 years. And that's, I think, a very interesting thing, because I think everyone is interested in bees. Everyone, I think, realizes that bees are important to our environment, that these, in fact, may be the canaries in the coal mine. And so we have this romance with bees, and people are interested. The New York Times story that was front page was apparently the most responded to story outside of a political story ever to run in the New York Times. And so I think there's a real public interest and desire to figure this out, and realizing that if these go, there's something really wrong, and we need to figure that out. And I'm an optimist. I hope we will. And we have a lot of different people, like sort of that whole idea of a social network, trying to work on this, not in a competitive way, but in that collaborative effort. So I'll conclude. I'll give you the website here. This is the Mid-Atlantic Region Apicultural Extension Consortium, which, of course, is a mouthful, so it's MERIC. That's where we're posting all our new stuff about what's happening with colony collapse. It's also, if you're interested in learning more about bees and beekeeping, it's the most relaxing thing you can ever do, because they'll tell you if they're mad. So you learn quick. And you can find some of that information there. I'll be glad to answer your questions after this. And thank you very much for having me and for hosting and everything.